Now we'll study about thermal properties of matter, heat and temperature. Heat is a form of energy transferred between two systems or a system and its surrounding due to temperature difference. Temperature is a measure of hotness of a body. SI unit of heat energy is Joule. SI unit of temperature is Kelvin, and degree Celsius is commonly used unit of temperature. Conventionally, the heat energy supplied to a body is taken to be positive, and the heat energy given out of a body is taken to be negative. Measurement of temperature. A measure of temperature is obtained using a thermometer. The commonly used property is variation of the volume of a liquid with temperature. Commonly used thermometer scales are Celsius, Kelvin, Fahrenheit. Relation between different temperature scales. At standard pressure, freezing point of water is 0 Celsius, 320 Fahrenheit, 273.15 Kelvin. These are lower fixed points. And boiling point is 100 degrees Celsius, 212 degree Fahrenheit, 373.15 Kelvin, upper fixed point. Uh, Freezing point of water is 0 degrees Celsius, 32 degree Fahrenheit, and 273.15 Kelvin. Boiling point of water are 100 degrees Celsius, 212 degree Fahrenheit, and 373.15 Kelvin. In Celsius scale and Kelvin scale, the temperature difference between freezing point and boiling point of water are the same. 0 key is absolute 0 because below this value we can't find any temperature in the universe. What's the absolute 0? 0 Kelvin. Conversion of temperature from one scale to another, Celsius to Kelvin. Kelvin, Celsius plus 273.15. Kelvin to Celsius, Celsius 3 minus 273.15. Fahrenheit is 1.8 degrees Celsius plus 32. Fahrenheit to Kelvin. It's easy when you do it by writing the values and doing directly. Graph of temperature in Celsius versus temperature in Fahrenheit is given. Boyle's law. When temperature is held constant, the pressure and volume of a quantity of gas are related as PV is equal to constant. We know that PV is equal to nRT. N is a constant, R is a constant. And when we keep the temperature constant, then PV also become constant. And this is Boyle's law. How you can memorize it? Like what we have to boil something, its temperature keep on increasing, and we fix the temperature itself. So PV is equal to constant. Next is Shaw's law. When the pressure is held constant, the volume of a quantity of the gas is related to the temperature as V by T is constant, ideal gas equation. And you have to memorize it like चाला ही कर दिया, pressure constant कर दिया, है ना? We have a lot of pressure on our brain na, to do this, to do that. But what? If we constant that pressure, that's gonna be very easy to do each and everything else. So it's a chala to constant your pressure. We know PV is equal to nRT. When P is constant, V by T is constant. PV by T is equal to mu R. PV is equal to mu R T. R is constant, universal gas constant, and its value is 8.31 joule per mole per Kelvin. Now the pressure versus temperature of a low density gas kept at a constant volume. As we increase the temperature, the pressure is increased. Volume is constant. With a constant volume gas thermometer is read in terms of pressure. The absolute minimum temperature for an ideal gas is minus 273.15 degrees Celsius and is designed as absolute zero. Absolute zero is the foundation of Kelvin temperature scale or absolute scale temperature. Now thermal expansion. The increase in the dimension of a body due to increase in its temperature is called thermal expansion. The expansion of length is called linear expansion. Expansion of area is called areal expansion. Expansion of volume is called volume expansion. The fractional change in dimension is proportional to change in temperature. The corresponding proportionality constant is called coefficient of thermal expansion or thermal expansivity. Here we are given types of thermal expansion, the dimension that change, coefficient, thermal expansion, and the relation. First is linear expansion. The dimension that changes length. Coefficient of linear expansion is alpha, delta L by L, delta T. Linear expansion or coefficient of linear expansion. Next we have areal expansion, that is delta A by A delta T. That is twice of linear expansion. And we have volume expansion, delta V by V delta T. That is change in the volume per unit of volume with the change in the temperature. That is 3 times of linear expansion. This shows that the coefficient of volume expansion for ideal gas is reciprocal of temperature. Yeah, more the temperature difference, greater we go to the expansion. For ideal gas equation we have PV is equal to mu RT. P delta V is mu R delta T. Dividing the equation we get delta V by V delta T by T. Delta V by V delta T is 1 by T. That's alpha. Areal expansion is twice of linear expansion. Volumetric expansion is thrice of linear expansion. Consider a cube of length L due to increase in temperature delta T. Length of cube increased by delta L in all direction. The coefficient of linear expansion is delta L by L delta T. Increase in area of cube delta A, final area minus initial area, and you have some calculations just to prove that thing that we know. Now the anomalous behavior of water. Water exhibits an anomalous behavior. It contracts on heating between 0 to 4 degrees Celsius. Okay, the volume of a gas amount of water decreases at its cooled from room temperature until its temperature reaches 4 degrees Celsius. Thus, water has maximum density at 4 degrees Celsius. इन्वायरमेंटल इफेक्ट से कैसा होता है ना, किसी भी चीज़ को हम हीट करते हैं तो वो क्या करती है, एक्सपेंड करती है ना, तो उसका वॉल्यूम क्या कर जाता है, इंक्रीज कर जाता है, डेंसिटी डिक्रीज कर जाती है. बट वाटर के केस में जब हम उसको 0 से लेके 4 डिग्री सेल्सियस तक हीट करते हैं तो रेदर देन एक्सपेंडिंग इट कॉन्ट्रैक्ट. ठीक है, कॉन्ट्रैक्ट हो जाएगा तो वॉल्यूम डिक्रीज हो जाएगा, डेंसिटी इंक्रीज कर जाएगी. तो मैक्सिमम डेंसिटी होती है 4 डिग्री सेल्सियस पे. इसके बाद जब हम टेम्परेचर इंक्रीज करेंगे तो फिर वो एक्सपेंड हो जाएगा, वॉल्यूम इंक्रीज हो जाएगा, डेंसिटी डिक्रीज कर जाएगी. Okay, now what are the consequences of environment? What are the effects of anomalous behavior?